Albert Einstein or Isaac Newton? Which one was more genius among the two most popular scientists in the world?
Can we say Einstein was a lot smarter than Newton?
No, actually, if you want to put them head-to-head, I think I'd put Newton ahead.
Einstein comes next after Newton.
My favorite physicist is Isaac Newton.
If Newton were around in Einstein's time, Newton would have done it all. If Einstein were around in Newton's time, not so much.
These are some of the most popular minds of today's generation, and everyone has considered Isaac Newton to be an unrivaled genius, meaning that there has been no genius like him till today. In fact, Einstein himself wrote in his autobiography notes that Newton was a creative genius of the highest order. But such brilliant scientists whose theories were accepted as the truth for 200 years. And even today, we are taught Newton's laws of motion in schools and colleges, while Einstein's theory is only introduced in degree colleges. But ironically, the first to challenge Newton was no one else, but his deepest admirer Albert Einstein himself. Well, let's do a small experiment. If I drop this ball from my hand, what will happen? Well, according to Newton, the ball will fall to the ground due to gravity, which is a force that attracts two objects to each other, like the ball and the earth in this case. But according to Einstein, this is wrong. Gravity is not a force. In fact, gravity is just an illusion, a deception, and the ball is not falling down, but rather it is moving in its own path. So is the ground moving up. And let me ask one more thing. If I put a ball on a table, tell me, is this ball in inertia or is there any force on it? In physics, inertia means the tendency of an object to retain its state. If it is in motion, it stays in motion. If it is stable, it stays stable until and unless some external force does not act on it. So in the example of this ball kept on the table, well, Newton would say it is in inertia because it is stable. But Einstein would say there is a force on it, the force of acceleration. In fact, when you drop the ball from your hand, then the ball comes into inertia. Well, you will find such contradictions when you compare the theories of both Newton and Einstein at the same time. But in the end, Einstein proved Newton's theories to be incomplete with his special and general relativity theory. And today, the world accepts this. So if Einstein proved that gravity, the very thing Newton is known for, wrong, then why did Einstein consider Newton as world's biggest genius? Was he just trying to act humble in his autobiography? Like when Magnus Carlsen was asked who is the greatest rated chess player, he skipped his own name and mentioned his inspiration, Garry Kasparov.
I think Gary is the best of all times.
And what have we learned in childhood about gravity? Was all that wrong? Well, friends, today in this video, we will exactly find out why we still need to study Newton's theory even when the world knows it's incomplete. What exactly was wrong in Newton's laws of motion, his mathematics and his explanations that Einstein saw and fixed? Even, we will also find out how this experiment, which is shown to visualize Einstein's gravity, can be misleading, due to which you are not able to grasp gravity properly. And in the end, what did Einstein see in Newton that made him consider him a bigger genius than himself? Considering all this rationally, we will better understand who was the bigger genius among the two. So get ready, because this video is going to challenge your understanding of reality. So let's get started. 400 years ago today, in 1633, the Roman Church threatened Galileo Galilei that if he did not stop promoting his scientific ideas, they would hang him. Galileo's findings were proving things written in the Bible as being false. At that time, people believed that our Earth is the center of the solar system and the Sun and other planets revolve around it. This model is called geocentrism. But Galileo saw 4 moons of Jupiter with his own telescope, which were revolving around Jupiter. This means not everything was revolving around the Earth. He also saw separate phases of Venus. This means that it is also revolving around the Sun. This was direct proof that the heliocentric model of Copernicus could be correct and the Church was wrong. But the Church did not accept this truth, and in the face of spreading this wrong knowledge and religious opposition, Galileo was sentenced to life imprisonment in 1633.
We declare that you, Galileo Galilei, We condemn you to formal imprisonment in this holy office at our pleasure.
He was banned from publishing research, writing books, and reading science. All was imposed on him. And in 1642, he died maintaining his truth. But like they say, the truth can never be suppressed, never hidden. Consider it a great coincidence that in the same year, 1642, on a day like Christmas, a person was born who would stand for this truth in front of everyone. It was like Galileo was born again in a different body, because this person was none other than Isaac Newton, born in Lincolnshire County in England. Sir Isaac Newton was born at a time in history when science was just beginning to be understood as a subject. Newton came from a troubled family. His illiterate peasant father passed away 3 months before he was born. When he was 3 years old, his mother married a wealthy man who did not even want to accept Newton. Newton spent his entire childhood in this turmoil, living with his grandparents in his mother's absence. And perhaps this feeling of abandonment gave him a sense of shock, which greatly shaped his personality. Living alone, not trusting anyone, keeping things to himself, extremely obsessive, taking revenge. These are some of the dark personality traits of Newton, which you will see throughout his biography. Like he made a list of his sins later on, in which he included his teenage thoughts. In that, he wrote that at one point he was so frustrated that he had thoughts of burning his mother and his stepfather. But anyway, his mother got divorced in a few years and he moved in with his mother. At the age of 15, she wanted Newton to leave education and work in their ancestral fields. But Newton was made of something else. In fact, even while farming, he would sit under an apple tree and solve math problems. Upon entering college, he realized within a few days that he was being taught outdated concepts. Just like there is no such thing as gravity in the physics of Aristotle, known as Aristotelian physics. Every object simply has a natural tendency to move from a non-rested state to a rested state. Like, for example, when a ball is dropped, it falls to the ground and comes to a state of rest. The bigger the object, the more its tendency will be to come to a state of rest. Now I'm going to ask you a common sense question. Give me the answer. I take 2 balls. One big with more mass and the other with less mass. Now, if I drop them together from above, which ball will fall first? What is your common sense telling you? The ball with more mass from Aristotle's perspective will have more tendency to come in the state of rest, and therefore the heavier ball will fall first. But Newton did not agree with this argument. Okay, Newton was having trouble accepting one more Aristotelian physics concept. He argued that a constant force is needed to keep an object moving forward. If the force is stopped, the object will also stop moving and return to a state of rest. Because remember, every object has a natural tendency to stay at rest. Note that for Aristotle, there was no concept of inertia, so no concept of gravity and no concept of inertia. Now, why did this bother Newton? Because his inspiration, Galileo, had already shown in 1589 with an experiment from the Leaning Tower of Pisa that when 2 balls are thrown together, both balls fall together irrespective of their mass. So there is no link between the mass of objects and them falling down first or last. And for this reason, in order to find the truth, Newton started self-studying the books of modern ideas of scientists and philosophers like Galileo, Copernicus, Descartes, Cavallari in June. Just imagine, you went to college and within a few days you realize that you are studying outdated concepts and you have to study on your own. Such thinking scientists do something different. He even made a special notebook named Questiones Quaedam Philosophicae, which means certain philosophical questions, in which they wrote a very beautiful thing. Aristotle is my friend, Plato is my friend, but truth is my best friend. After self-studying for 4 years in his university days, he started to gain clarity in the concepts of motion and gravity. When Newton saw things falling down, 2 powerful thoughts came into his mind, and both thoughts led to 2 major inventions. The first thought, why do these things fall down? Is this tendency due to some force And does the same force keeps our moon in Earth's orbit? Until that time, Kepler's laws of planetary motion were invented, and then Newton knew that the moon orbits the Earth in an elliptical orbit. But no one knew why this was happening. For some reason, it was just assumed that it orbits. So all Newton had to do was to prove in some way that the same force that is pulling the apple down is also keeping the moon in orbit around the Earth. And in this way, the concept of gravity was discovered. Now, this idea never occurred to the philosophers like Aristotle, nor Galileo, nor Copernicus. No one ever came up with the idea that a force that attracts two objects to each other, how is it keeping the moon in orbit around the Earth? Why doesn't the moon crash into the Earth? Well, this was understood from one of Newton's thought experiments, the example of Newton's cannonball. If you shoot a cannonball from the Earth with less force, the Earth will attract it downwards and it will fall down. And on the other hand, if you shoot it with a lot of force, it will go straight into the space just like rockets do. But if you apply just the right amount of force so that the Earth can't pull it down and it doesn't accelerate forward enough to go straight into space, then it will keep falling towards the Earth but never actually touch the ground. This is what they call an orbit. Just like the moon is also constantly falling towards the Earth, but never actually touches it. He just had to prove it mathematically, but how did he do it? Just wait and watch. The other thought that he had when he looked at falling things was that as soon as any object falls down, we can easily measure the speed of its fall using the formula of distance upon time. But the problem is that this formula only calculates the average speed of the object falling down. If we want to, let's say, know the exact speed or velocity of the apple at the exact point 2 seconds after falling, how can we calculate that? Now, to answer this, they literally invented a new branch of math, which is used in literally 80% of physics today: calculus. Physics is all about change, and calculus describes change. In the universe, only one thing is constant, and that is change. Calculus is such a mathematical tool which helps them to predict changes. How will something evolve? Calculus describes motion, like the equation of a falling object. Calculus describes electricity and magnetism, like Maxwell's equations. Calculus describes general relativity, like Einstein's field equation. Calculus describes quantum mechanics, like in Schrödinger's equation. Calculus also describes thermodynamics and much more. So Newton basically learned to mathematically describe the motion happening on Earth. Now he just had to learn to mathematically describe the motion of planets in space, so that he could prove that gravity works the same way on Earth and throughout the universe. It is a universal force. And then, after years of effort, he finally corroborated the falling objects, moon's motion, and Kepler's third law of elliptical orbit, and developed the universal law of gravity. This is the equation, also known as the inverse square law. Now, one point to note is that Newton developed this universal equation, but the idea of the inverse square law was already there, for which Newton gave credit to Borealdus and Borelli, who had first hypothesized that there is a force from the sun, the impact of which decreases with the square of the distance, and no one could connect these ideas to Newton's way or prove them mathematically. It was possible only for Newton because he was a mathematical genius. And this teaches us one more thing. In scientific discoveries, from my experience, 60% is the role of imagination and ideas, and 40% is the role of math that helps to prove that idea. The idea gives direction, and math takes it there. That's why Einstein also said, imagination is more powerful than knowledge, so never stop your imagination. From this learning, Newton then published his 3 laws of motion in his book Principia Mathematica, along with the concept of gravity. This book created such a strong framework for modern physics that Newton's book became like the Bible of science. And Newton, happy with his work, passed away on 31st March 1727. Now, after knowing about Newton, scientists started using Newton's model to predict the orbits of planets easily. Problems started to appear in Newton's theory when a small planet, Mercury, was not obeying Newton's laws of motion. The Newtonian model was not able to predict the orbit of Mercury. Every time the calculations were off by approximately 43 arc seconds per century. Was there a hidden planet somewhere whose gravity was interfering with Mercury, causing these miscalculations? This is exactly what Urbain Le Verrier thought in 1846. He proposed a missing planet Vulcan, but this missing planet Vulcan was never seen by anyone. And from this point, questions began to arise on Newton's theory due to this calculation mistake. You won't do anything in life, nothing. Do you understand? These were the words of one of Albert Einstein's teachers, who were troubled by Einstein's stubborn attitude. Today, the whole world certainly considers Albert Einstein as a genius. Perhaps when he was a child, no one would have thought so. Well, Einstein's childhood was very interesting. He didn't even learn to talk until he was 4 years old. His parents were scared that he might have a speech defect. Even today, children who don't learn to speak until late are said to have Einstein syndrome. In his childhood, Einstein was a quiet and calm child who daydreamed in his own world. He was average in studies, but he didn't like the concept of rote learning and unnecessary rules in school. He saw school as a kind of jail, where children are made narrow-minded and their imagination and creativity are suppressed. Because of this attitude, some teachers didn't like him. But although Einstein didn't like memorization, he was very fond of asking curious questions, doing thought experiments, and learning math. And because of this, by the age of 12, he had taught himself calculus and other advanced math and geometry. From the age of 12 to 14, he also started doing real experiments, like calculating the speed of sound, timing echoes, making model flying planes and steam engines. At the same time, there was a question which troubled them a lot and which was going to change their entire life. He was very fascinated by the concept of light, and he often wondered if they could convert themselves into a beam of light and roam around the entire universe. What would he see from his point of view? What would the universe look like? Once again, imagination. He used to think a lot about time as well. Why is it so fundamental that it only moves forward in one direction? Understanding those times is very important now, because only then will we understand where the inspiration to make Einstein came from. So at that time, two theories of physics had become the cornerstone of our understanding of reality. One was Newton's laws of motion, and the other was Maxwell's laws of electromagnetism, which were given by James Clerk Maxwell in the 1960s. And they revealed that light was nothing but electromagnetic radiation, and its laws describe the motion and propagation of light. Now, it was not proved at that time, but Maxwell's equations were suggesting that the speed of light should always remain constant for every observer, which is approximately 300,000 kilometers per second, whether any observer is in motion or then he is static. Okay, understand this from an example. Let's say you are traveling in a spaceship at a speed of 200,000 kilometers per second, and a spaceship is standing still in front of you. Now, if you accelerate from that spaceship at a speed of 2 lakh kilo per second and shine a beam of light, how much will this observer measure the speed of light? Well, Newton's common sense would say the speed of light is 300,000 kilometers per second plus the velocity of the spaceship, which is 200,000 kilometers per second, is equal to 500,000 kilometers per second. Isn't it simple? I mean, if you were to launch a missile at a speed of 100,000 kilometers per second, the missile's velocity would add to the spaceship's velocity, and the net velocity would be 300,000 kilometers per second. Okay, I'm interchanging speed and velocity here so that more people understand it, because speed is a more common word. So this is simple Newtonian relative motion where two speeds should add up. But in the case of light, it doesn't happen like that. The observer will only see the speed of light as constant, i.e. 300,000 kilometers per second. In fact, the speed of light will always remain constant for every observer. Now, since light is an electromagnetic wave to begin with, Maxwell's equations were raising some interesting questions. One beam of light will have to travel through some invisible medium, Like, for example, sound waves travel through the medium of air. So what medium will light travel through? Well, this medium was named luminiferous ether, or simply ether. But the problem was that whether ether existed? No one had seen it, nor had anyone proved it, which was then attempted to be proved in 1987 by two American physicists, Albert A. Michelson and Edward W. Morley. And to their surprise, though they went to prove an existence, but they proved that a medium like ether does not exist at all. And yes, they also validated Maxwell's claim that the speed of light is indeed the same for all observers. Now, how was this experiment proven, and what is the whole detailed story between these events I have already covered in this video, which you can see if you want a detailed perspective. For now, we will just focus on the main points. So now we have finally reached that point in history where a lot of questions were raised about Newton's theories. If Newton says that all motion is relative, that is, velocities add up, as we saw in the spaceship example earlier, then how did Michelson and Morley prove that the speed of light is constant? Why doesn't it add up like other things? Is light special and behaves differently? This is where Einstein comes in and the beginning of the special theory of relativity, in which Einstein considered light as a special element. Einstein published a scientific paper in 1905 to clear this confusion, which completely changed the perspective of the physics community. The paper was called Electrodynamics of Moving Bodies, and in this paper, they basically rejected the entire concept of ether, along with pointing out some glaring faults in Newton's laws. In this paper, Einstein basically ousted ether and replaced it with a very new and fascinating concept of space-time. So basically, what we are seeing everywhere in the universe is not just space, but space-time, which is made up of 3 dimensions of space and 1 dimension of time. Space and time are fundamentally intertwined, inseparable. There can be no space without time and no time without space. According to Einstein's model, it was a totally groundbreaking idea, which was against Newton's theory. In fact, going forward, Einstein will publish multiple such concepts, ideas and theories that will expose the incompleteness of Newton's theory. So what were those ideas? So let's move on. Now going forward, we will do a direct one-on-one comparison of Newton versus Einstein's worldview, because somewhere these two scientists' views seem quite opposite. In school, we are taught Newton's laws. But then why does Einstein say that Newton is wrong? Who should we trust after all? And Einstein challenged Newton's ideas, saying that the apple doesn't fall down, but the earth is accelerating. So how can earth accelerate on all 4 axes? Okay, now very few people will even know that there are 2 types of gravities, one real and one fake, and the gravity you and I experience is fake gravity. These concepts are very fascinating. And don't worry, these mind-blowing concepts that make up our reality, I will cover in detail in the next and last video of the series, and in such simplified way that even if you are from an arts or commerce background, you will understand it intuitively. The next part will come within a week. See you very soon. Jai Hind.